Welcome to Excel 2010 Statistics video number 50. Hey, if you want to download this workbook, Business 210 Chapter 5.xlsm, click on the link below the video. Hey, we're going to start on the sheet B2 for Binomial Video 2. Now, in our last video, we had an introduction to binomial experiment, calculating binomial probabilities, and the Binom.DIST function. So, we're going to look at three examples in this video here. The first one, a flight from Oakland to Seattle occurs 6 times per day. The probability that any one flight is late is 10%. What is the probability that exactly 2 planes are late? Less than 2 planes are late? And what is the mean and standard deviation? Well, we can't just take 2 and multiply by 10. And we saw last video how in order to calculate a probability here, we either have to calculate all the individual sample points or experimental outcomes and then the probabilities associated with those and then add them, or we can use the binomial probability function formula or our Binom.DIST function. Now, what do we got to do first? If this sounds like a binomial experiment, then we got to make sure that it meets the 4 requirements. So, are there a fixed number of identical trials, which we denote by n? Yeah, there's 6 flights per day, so yes. Each trial only results in a success or failure. Well, what is our success? Flight is late. Success is late? Well, for this example, yes, it is. So yes, it's either late or not late. Now also, remember, what categories are these? We have, or what level of variable are these? We're just talking about late or not late, and there's no order to it. So that makes it nominal, right? Not only that, but since it's nominal, and in addition to that, there's only 2 outcomes, success or failure, late or not late. That means 2, which is bi, so binomial. That's where we get that word binomial. Number 3, p remains the same for each trial. Yeah, 10%. So we got a yes there. And finally, all events are independent. Yes, one mechanical failure on one plane is not going to affect the mechanical failure on the next plane. So yes, for all 4, as soon as we have 4 yeses, our binomial requirements are met. We can use our Binom.DIST function. All right, let's list our variables. A success, what's a success? Late plane. And success, right? Failure. Plane on time? Failure is a plane on time? Yeah, for this example here. N is number of flights per day. We got an n there. Our x, that's our random variable. That's going to be number of planes late. Planes late in 6 tries. 1 day. Now, we have 2. We're going to do a bunch of examples for 2, again, to see how the Binom.DIST function works in all the different comparative operator situations. And finally, our pi, probability of success, equals probability late. That's so funny. And that's going to be 0.1. All right, so we've gone through the 4 requirements for binomial, listed our variables, and now we can calculate. We're going to use the Binom.DIST. Now, last video we saw how to list exactly, and x, these are all the possibilities, right? There could be 0 planes late in 1 day, 1, 2, 3, 4, 5, 6. We saw how to build a little table like this and build a chart, which is very important. You can see this is a broken link. That should have not. This is going to be our x. So here's a picture of this one here. And this looks different. In our last video, we saw our chart here. Looks slightly different. And we'll see a couple more examples, and the charts each time look different. But here's the deal. this chart will help us visually as we learn how to calculate all the different probabilities associated with the 2 and the comparative operators. Visually seeing how we add up cumulatively will help for our Binom.DIST function. All right, x equals exactly 2. That's pretty straightforward. We go equals Binom, and there's our dist. The number of successes, 2, exactly 2, comma, our trials. Actually, should have put a 6 there. Here's a great trick. You can put your cursor at the beginning and hit a space. It suspends the formula, because the definition of a formula is equal sign as the first character in the cell. So if you put a space, it's no longer a formula. So I'm going to put a 6 there. Number of trials. Now notice it's hard. If I click right there, it's because that chart's under here. I might mess this up. It's sometimes safer to come up and click here. But I want to for the video, so I'm going to click here. So I'm going to use my arrow key and get to the end. I need to type that comma. And then the probability of success. And then cumulative. This is 0, because this is exactly 2. So there's our probability that we get exactly 2. And the height, and when you do a column chart like this, the height of that chart represents the probability. Now, greater than or equal to 2. Now, if we look over here, greater than or equal to, that means we need to add this one, and this one, and this one, and this one, and the 6. Now, those are showing as 0, but there's some teeny probability there. That's just formatting. But we need to add those all up. So the way the Binom.DIST function works is it always goes from the lower to whatever x we put in. So this is greater than or equal to 2. So if we put a 2 in here, it would add this one, and this one. But we want greater than or equal to all of these. So first, we're going to have to take that 2. We're going to have to put a 1 into the function. Then it'll add these up. And since all of the area always equals 1, we take 1 minus the sum of these 2, which is from our Binom.DIST. So equals 1 minus Binom.DIST. All right, number of successes. Well, we can click on here, because oftentimes it gives us that greater than or equal to 2. But we know we want this included, so we have to subtract 1. Remember, we got to throw a 1 in there, so that it adds all up all these, and then that's subtracted from the 1. All right, our number of trials, our probability, and cumulative, this is 1 for true. The cumulative distribution function, 1. That means from small to whatever x we put in. All right, that is our probability that we could get greater than or equal to 2 flights late in one day with 6 total flights. All right, how about greater than 2? So everything greater than 2. Well, this one's pretty straightforward, because if we do our same similar setup, this, and this. So if we put a 2 as our x into the Binom.DIST, it'll add all these up, and we'll subtract it from 1. So I'm going to say number of successes, comma, our trials, our probability. Cumulative is 1, and there we go. So that's all of the greater than. What's the probability of getting greater than 2 flights? Pretty darn small. All right, now what about less than 2? All right, so less than 2 means these 2. So we're going to just do our Binom.DIST. It gets them from the small number to whatever x we put in. But since we have a 2, we have to subtract 1 to get to here, because we only want it to go whoop. And this is a small one, 0 to 6. In our next example, we'll have one 0 to 42. And so knowing how to use the Binom.DIST function is quite useful. All right, so this is just straight Binom.DIST. Number of successes. OK, we're putting a 2 in, but right now it would add from there to there. So we need to move back 1. So we subtract 1, comma, the number of trials, probability, and then cumulative is 1. Now, we want 0. So now we've asked the question, what's the probability of getting less than 2? Right? So there it is, 0.88. Now we want less than or equal to 2. So this one's got to be a little bit bigger than that one. Same exact thing, except for we're going to let it go it's just a straight from 0 to 2, so we just throw that 2 into the Binom.DIST, and it will give us our answer. So binom, number of successes, comma, our trials, our probability, 1 for cumulative, and boom. Now, just like we did in the last video, you can check these. As you're learning, it's very helpful to check. So we could literally come here. I'm going to check exactly 2. Well, I already did that down here. The greater than or equal to 2, so I do the sum of greater than or equal to, all of those. And that's just formatting. That is just because we're showing 2 decimals. If you increase the column width, you can see it's there, or you can manually do it here. Greater than 2, Alt equals is the keyboard shortcut, and greater than 2, I just add up 3 to 6. We're checking less than 2, Alt equals, just those 2. And finally, Alt equals, this one is greater than or equal to 2, so greater than or equal to 2. Less than or equal to 2. Notice what did I do there? I highlighted the wrong range, so I came in here and highlighted this. Anytime you highlight something, it's automatically, as soon as you start typing or clicking, it replaces it. Useful as you're learning, but if you use these on a regular basis, then certainly knowing how to do each one of these. And of course, just like last video, we went through one, for a given x random variable, we went through all how to do these, use this function with all the different comparative operators. All right. Now, we want to talk about mean and standard deviation. And actually, let me zoom in here. Alt-WG. There's a great new formula. If you've gone through the 4 requirements for Binom.DIST, you can use this and this. It's much easier to do than these. Remember, we saw the mean and the standard deviation for a discrete probability distribution. These are the formulas. And these formulas require that you have the whole distribution. And again, later, especially when we get into hypothesis testing and things like that, you don't want to build all this. You want to just quickly be able to calculate it. And these formulas are quick and easy. However, we're learning this here, so we want to attach the process that we already did, see that we can get the mean and the standard deviation from our distribution, and then do our new formulas and see that they'll give us exactly the same answer. All right, so mean. Oh, yeah, it was just simply multiply each x times its associated probability, and then add. And the sum product function is perfect for that. So array 1, those are our random variables, comma, those are the, notice I made a selection error there, but it's no problem. As long as the dancing ants are moving, it's still editable. So I click there. As long as those are moving, you can go in any direction. Even if you accidentally enter it, you can then do what we did before, highlight it and redirect it. Oh, 0.6. What does that mean anyway? 0.6 flights in one day are late? That would be hilarious. You're watching all 6 flights during the day, and here's this 5.4 flights coming in on time, but there's that 1.6 one, 0.6 of an airplane coming in late. No, that's why it's called the expected value, right? It's just a long run average used for planning and whatnot. Means less than 1 plane per day is going to be late. All right, now standard deviation. We saw how to do this before. All in one formula. We have to take our deviation, each x minus the mean, square it. That'll give us a column of values, and we multiply it by our column of probabilities. We saw how to do this before, all in one formula using sum product. So let's do it. Equals sum product. The array, well, I'm going to put it in parentheses, all the x's minus our mean. Now, those will give us a list of the deviations. And of course, as we saw before, if you hit the F9, you can see, oh, there's the deviations. But we got to square each one. I'm going to Control Z. If you use the F9 key to evaluate, always Control Z. Caret 2. All right, that gives us this little part right here. But notice each one of those are multiplied by that. So we array 1, type a comma, get our column of probabilities, close parentheses. This will give us the variance. But we don't want that. We want the square root. So we go square root. Or raise it to the half. Wow, I can't quite click there. I'm going to, with my cursor right there, hit the end, E-N-D key. That jumps the cursor to the end. Close parentheses. All right, now, here's the magic of Binom.DIST. It's simply n, our number of fixed trials, times our probability. Let's try it. Equals n times our probability. And this sort of makes sense, right? If the probability for any one day is plane being late is 0.1, and we have 6 flights, 0.1 times 6 will give us our average. And there it is. Pretty cool. Similarly, if we look at the square root of n times p times 1 minus p, that right there we already calculated right there. So we simply take this times 1 minus p, that's the probability of being on time, and take the square root of it. So times and then 1 minus. So it's our mean times the probability of being on time. Pretty cool, these two. And what again, the mean tells us on average for any given day how many planes are going to be late. And the standard deviation tells us the variation, the spread in the data, how fairly our mean represents our data points. And if we had other flights, we could compare the standard deviation. It will tell us, which mean represents its data points more fairly. All right, so this great example, we saw the probability with an airplane being late, and we did our Binom.DIST function, and a bunch of other cool things, mean and standard deviation. Let's go over and look at, actually, let's scroll down here. I want to do an example from the PDFs. I'm going to go over to our PDFs. This is download, and we'll look at this example. The probability of sitting in traffic on the West Seattle Bridge during rush hour is 0.5. During your next 7 rush hour bridge crossings, what is the probability that you will sit in traffic 3 times? 5 or more, mean and standard deviation. All right, so is it a binomial experiment? Fixed trials, yes, 7. Independent, more or less. Because of the car, the car wreck on one day is highly unlikely that it's going to affect the traffic the next day unless it blows up the whole bridge. Success or fail, yeah, you're either stuck in traffic or not stuck in traffic. Man, I'm great at picking examples here. Stuck in traffic is a success. Ugh. And then pi, same each time. Yeah, we'll assume it's 0.15, and using the complement rule, the probability of not getting stuck in traffic in rush hour traffic is 0.85. All right, let's go over to Excel. I'm going to type, actually, let me cheat here. I'm going to copy this. And I'm going to type so our n will be 7. Our x will be, we'll have various x's. So we're going to have to put a column over here for x. And our probability is 0.15. And let's see. Success equals traffic. Days across bridge. Whoops. Number times so number of times stuck in traffic in 7 times. That'll be our x. And our pi will be all right, let's do our, I'm going to do our x, x, x. And then I think we had a, what is the probability you sit in traffic? 3. Oh, so exactly 3. And 5 or more times. And then we'll do our mean and our standard deviation. All right, exactly. We'll do Binom.DIST number of successes. That's going to be 3, comma, our trial 7, our probability that, and this is comma 0. So 3 times. Wow, we have a 6% chance in the next 7 days we'll get stuck in 3 times. How about 5 or more? Number of successes. I didn't put it in a cell, so I'm going to put it right here. Binom.DIST number of successes. Now look, I can't quite get to that cell there. There's a couple ways I do it. If I'm creating a format, I can use my arrow keys, and my arrow keys will go over and get that 5. Now this is 5 or more. So we're going to have the Binom.DIST calculate everything from 0 times stuck in traffic up to 5, and then subtract that from 1. So if we want, do we want 5 included? Yes, we do. So we have to subtract and go down to 4. So I'm going to minus 1, trial 7, comma probability, and this is cumulative. Now this will give me everything from 0 to 4. So 0 to 4. So I'm going to calculate 1 minus that, and that'll give us above 5 or more. Our mean equals our n times our pi. And the here's another one of those situations like the plane. What does that mean? It means on one of those days we'll have 5% of our car stuck in traffic, but the other 95% will not stuck in traffic. No, that just means the long-term average. On average, over those 7 days, we're going to be stuck in traffic 1.05 times. And finally, the standard deviation will be the square root of our mean times the complement 1 minus our pi. Of course, we had to do parentheses because we have to force that subtraction first before multiplying. All right, and let's see, did we leave anything out? Oh, here's in the PDFs, you can see how to calculate it longhand using the formula. Luckily, we have the Binom.DIST. All right, now, one last example. Let's go over to the sheet 2.5. I'll scroll up here. So here's our third example. Highline found that 16% of its students withdraw from Accounting 202. In the current class that has 42 students enrolled, what is the probability that 2 or fewer will withdraw? More than 3 will withdraw, or exactly 4 will withdraw? What is the expected number of withdrawals? All right, so here it is. Let's go through our requirements for binomial experiment. Fixed number of trials. Yeah. There's 42 students, so each one either withdraws or doesn't withdraw. Each trial results in a success or failure. Success is withdraw. Wow, 3 straight examples where our success was actually looking like a failure. But we're going to define success as withdraw. P remains the same for each trial. Yeah, 0.16. And finally, all events are independent. Yeah, you know, one student's reason for withdrawing is highly unlikely it's going to affect another student. All right, so all 4 requirements are met. Now I already listed our variables here, and here is a chart. Now again, we saw how to create this distribution last video, and this is an example where there's a lot of n's here, 42. Just use your bi.dist with the 0. It calculates the height of each column. But notice how our distribution looks, right? It's all clustered here, and it looks kind of a little bit like a bell shape right here. But then there's all way out here, incredibly small You know, they're so small they don't even get visually portrayed on this chart. You can see over here. So what's the probability that everyone in the class will draw? Nothing, basically. All right, so let's calculate some probabilities. Probability, and I listed my n's here and my x. So n is 42. X is going to be number of successes. That's number that withdraw from accounting 202. And the probability of withdrawing for any one is 0.16. All right, 2 or fewer. Binom.DIST. Our number of successes. We're going to start with our 2. Now, what would this 2 do? 2 or fewer. Go 0, 1, 2. Well, if we throw this 2 into there, it'll cumulatively go from 0 to 2, and that's exactly what we want. So comma, trials, 42, comma, and the probability, 0.16. Now, this is cumulative. We're going to put a 1 because we want it to go from that 0 all the way to the 2. So 2 or fewer. Not so like 2.5, almost 3% chance that 2 or fewer will withdraw. How about exactly 4? So Binom.DIST. If only I could type. You can see what a bad typer is. I make mistakes all the time. All right, so number of successes, exactly 4. Number of trials, 42. Probability, 0. 0 is for cumulative. Now, you know that that is not possible, right? What's the definition of probability, right? Some number between 0 and 1. So obviously, I made a mistake. Yeah, so I accidentally typed a negative sign in front of there. So 9.7, almost 10% chance that exactly 4 students will withdraw. All right, what about more than 3? OK, so now we're talking about on the upper end. We always, as soon as we're getting on the upper end, the functions by default don't give us that. So we're always going to have to take 1, which is all the probability, minus from 0 to whatever it is. Well, we want more than 3. So we can just dump the 3 into the Binom.DIST, and it will go from 0 to 3, and then subtract that from 1. So the number 3, comma, trials 42, and probability of success 16, comma. And we definitely want 1 for cumulative. OK, so more than 3. Wow, the probability that there will be more than 3 is 92%. Wow, that's a hard class. All right, now what about our mean? This is on average for the whole class. How many students on average will withdraw? N times P. And what do we get? 6.72. So again, you see that 7.2 of a student walking out withdrawn. So on average, right? This is the long line average. Even though we have discrete variable here and we can only count 1, 2, 3, 4, 5, 6, this is our average, an estimate. All right, so we saw 3 examples here. And we also saw some different looking distributions for the Binom.DIST. In our next video, we'll actually talk more about how the visual portrayal of this in a chart, the look and shape of the distribution changes as n changes and p changes. All right, see you next video.